Hi, this is Mr. Kingsbury, and I've got some more notes for you. I've got my heading all set up here. Remember, we're doing Algebra 2. That's our subject. Our unit is absolute value, and today our topic is going to be characteristics. As I mentioned, I am Mr. Kingsbury. Make sure you put today's date down and the period that you have me. Our essential question for the day is, what are the important characteristics of an absolute value function? Now, for just a minute, I'm going to go back to our transformation notes, and I'm going to borrow the general form of an absolute value function. If you'll remember, it looks like this. Y equals A times the absolute value of x minus c plus d. Now, in the transformation video, I spoke about how A, C, and D each handled different things. They made the graph go left or right or up or down, made it thinner, made it fatter, or reflected it over the x-axis. That's all very true. It turns out that these values also can be used to identify some very important characteristics. The very first one, and probably the most important one, is the vertex. So let's start with vertex. The vertex is either the highest or lowest point on the graph. So we'll say the highest point, which is called a maximum, or the lowest point, which we'll call a minimum, on the graph. What's really cool is, for us, for absolute value, the vertex is the point created by the c values and the d value. So the c value here, when you read it, becomes the x value of the vertex, and the d value becomes the y value of the vertex. It's kind of a neato thing there. What's awesome is those feed into a couple of later characteristics. The next one I want to look at is domain. The domain of a function is all the possible x values, of course. For us, in this case, it's just going to be all real numbers. That's pretty easy. Absolute value is pretty straightforward like that. Gotta love it. Along with domain, we have the range. And just as I've defined the domain as all possible x values, the range is all possible y values. Unfortunately, it's not quite as simple as domain. It's going to depend on whether the graph opens up or it opens down. So here's what I mean. If the graph opens up, it looks like a V. If it opens down, it looks like an upside down V. Now, if you aren't actually given the graph, you can also tell by looking at the A value. A positive A value means that it opens up, and a negative A value means that it opens down. Now, as I mentioned, the range is all the possible y values. So it will start with the vertex here, start with the y value of the vertex, and it's either going to be all the y values bigger than that, that's this case, or it'll be all the y values smaller than that, that's this case. And remember what we said? We said up here that d is the y value of the vertex. So when we have a situation where the absolute value graph opens up, our range will be y is greater than or equal to d. And in a situation where it opens down, our range will be y is less than or equal to d. Not a big deal, no worries. Let's see, next up we have the x-intercept. This is where the graph crosses the x-axis. it is also where the y value equals 0. That's important to note. In this case, in the case of absolute value, there could be as many as 2. Or there could be 1, or there could be 0 x-intercepts. So what does that look like? Well, if there's 2 of them looks like this. Here's my coordinate plane. I'm just sketching it real quick for you. Either the graph crosses like this, or it's upside down like that. No big deal. Here's what 1 looks like. Again, here's my coordinate plane. In this case, this is interesting. The graph comes down, it hits the x-axis, and it goes back up. Or if it's it's flipped, it goes up, hits the x-axis, and comes back down. This is called a bounce. And in the case that there's none, you guys probably figured this out. It just means that the graph doesn't even come close to the x-axis. Excuse me. So it looks like this. It's above it or it's below it, but it doesn't cross it. Probably would help if you could see the pictures. So here's 2. Here's 1, the bounce. Here's none. Sorry you didn't get to see me actually draw those, but there they are. Cool. Now, once you start talking about, I should mention, well, there's not really a quick and dirty, fast way to find these. You can plug in and solve. We're going to use the calculator, so that's going to help us. I'll show you how to do that, no big deal. Once you talk about x-intercept, the other thing you have to talk about is the y-intercept. Let me make my little column here off to the side really quick. So the y-intercept is going to be, of course, where the graph crosses the y-axis. There we go. So next up, what are we on? Number 5 here, y-intercept. And that is where the graph crosses the y-axis. It is also where x equals 0. And once again, there's a couple of ways that you can find them. You can certainly use your calculator. You can also plug 0 in for x and solve. I'm going to use the calculator. I also want to mention that there will always be 1. There will always be 1 y-intercept. The way that this function is set up, it will always cross the y-axis exactly once. The only other thing on here that we should talk about is called the line of symmetry. Some people call it the axis of symmetry. They're the same thing. Basically, if you were to fold the graph in half, or if you were able to fold it in half and have both sides touch, the line or the fold that would result is the axis of symmetry. Another way to say it is that it is the imaginary line a graph could be folded on in such a way that both sides would match up perfectly. The axis of symmetry is going to be the equation, or the line of symmetry is going to be defined by a specific equation. Think of it as like a mirror. Like if you were to take a function and there was a place you could put a mirror, and one side would be a reflection of the other, that place where you would put the mirror, that's the line of symmetry, or the axis of symmetry, depending on how you want to call it. Anyway, the equation we would use is simply x equals the c value. Pretty straightforward stuff. So now that I've given you the 6 major characteristics, remember they were domain, range, vertex.
Teachers, for those of you who signed up to assist with the t-shirt design, we're meeting in the lecture hall. And if you didn't sign up, but if you'd like to be a part of it, we're meeting in the lecture hall. Thank you. And we're meeting at 4:45.
And there was Mr. Watson being on my video whether he knows it or not. This is what happens when you record videos after school. Anywho, so the characteristics were domain, range, x-intercept, y-intercept, vertex, and line of symmetry or axis of symmetry. Let me just give you a couple of examples, and then we can be done with the notes. So let's say we have y equals 2 times the absolute value x plus 1 minus 6. Now, I don't know if you remember, but originally, when I gave you the general formula here, we had a minus between the x and the c value. So if I really want to understand what the c value is, I really need to rewrite this not as x plus 1, but instead as x minus negative 1, like so. That way then I have that minus and I can see that my c value is actually negative 1. So this will be my a value, this will be my c value, and this will be my d value. So let's go through this. So my domain is going to be all real numbers. I'm just going to use this funky R. I don't know if you've seen it before, but it means all real numbers. My range is either going to be y is greater than or equal to my d value or less than or equal to my d value. So my d value is negative 6. The question is, does this bad boy open up or down? Well, it's a positive a value. Positive a value means it opens up, like this. That means I use a greater than or equal to. So my range will be y is greater than or equal to negative 6. My vertex will be c comma d, which in this case is negative 1 comma negative 6. And my line of symmetry will be x equals c, which in this case is x equals negative 1. So far that's 4 out of 6. All that's left now are the x-intercept, or intercepts, you know, what might they be? And we also need to do the y-intercept. And to do those, I'm going to use a calculator. I'm just going to graph this bad boy. To do that, I'm going to go to y equals. Clear that out. I'm going to type this in. 2 times the absolute value of x plus 1 minus 6. How do I do that? I'm so glad you asked. Let me zoom in. Here we go. So, hold on one second. I bet I can make that prettier. That's a little bit better. So I'm going to go 2. And I just learned this today. I believe you can hit alpha and window. Yeah, and it takes you right here, and you can choose absolute value as the first option there. Cool. And then we'll do x. I'm going to hit this for my x. Oh, you can't see. Man, oh man, I zoomed in too much. Let me zoom out just a little bit so you can see what buttons I'm looking at. Here we go. Here's my x button right here. So I hit x. Wow, that's hard to read, huh? There we go. X, I believe it is plus 1. Then to get out of the absolute value, I need to hit the right button. That'll take me out of the bars, and then I can go minus 6. I believe that's right. It is. Now I can graph it and take a look. and possibly read my x and y intercepts off of the graph. It looks like my x-intercepts are at negative 4, 0, and 2, 0. I want to double check those, so I'm going to go to the table. See right here in blue, I don't know if you can see my pencil pointing, look at the graph button. Right above it in blue it says table, so if I hit second and that button, it will take me to the table. Now I believe that I thought that my x-intercept was at negative 4, 0 and at 2, 0. So let's see if I'm right. Let's see, let's go up here. Sure enough, there's negative 4, 0. And if I go down here, there's the other 0 in the y column at 2, 0. So my x-intercepts are negative 4, 0, and I broke my lead. I've done that like 6 times. And 2, 0. The y-intercept then is actually going to be a lot easier than the x-intercept. And the reason for that is, there we go. There is always an x value of 0 on your table. So the y-intercept will be 0, negative 4. 0, comma, negative 4. And there's example 1. Now let's try example 2. Let's see, we're going to go with y equals negative 3 times the absolute value of x plus 2 plus 6. Alright, so my a value will be negative 3, my d value will be positive 6, and I know it looks like my c value is going to be 2, but remember, this is really built with a minus, so this should be x minus negative 2. So my c value will be negative 2. Let's see if we can't blow through this then. So my domain will be all real numbers. My range will start with y. It is a negative a value, so I will use less than or equal to, and then I put my d value, which is 6. Y is less than or equal to 6. My vertex will be the c value, comma the d value, so that's negative 2, comma 6. My line of symmetry will be x equals c. I'm getting really tired of breaking lead. C is negative 2, so I get x equals negative 2. Then all that's left are the x-intercepts and the y-intercepts. Intercepts. And honestly, to find those, I'm going to go back to my calculator. That's a little bit of a shine. So y equals, and I am going to put, let's just clear this out, negative 3. I'm going to hit alpha F2, enter. That gives me my absolute value bars. X plus 2. Then I will push the right arrow to get out of the bars. And I will go plus 6. And I can go to my table again, and look, there it is at negative 4, 0, and again at 0, 0. So that's awesome. So my x-intercepts are negative 4, 0, and 0, 0. And then my y-intercept will be, let's take a look, let's find x value 0. There it is. Looks like it's the point 0, 0. And that is characteristics. Thanks for hanging. I'll see you.